Or when is December 23rd? Oh, another hard one. I haven't even finished this one yet. Geez, things is piling up. It's not looking good. Alright, let's take a look at this one. Find minimum diameter after merging two trees. There exists two undirected trees with n and m nodes, number from 0 to n minus 1 and 0 to m minus 1 respectively. You are given two 2D integer array, edges 1 and edges 2, where, okay, so these are the edges of the first and the second tree. You must connect one node from the first tree with another node from the second tree with an edge. Return the minimum possible diameter of the resulting tree. The diameter of the tree is the length of the longest path between any two nodes in the tree. Okay, for one, I think this is a very interesting question. Okay, it's a very interesting question. For two, I'm not sure. I'm not sure if it requires some obscure theory, that someone spent years researching to get out. I'm not sure. Well, there's definitely there's no way. I would say would they even allow us to brute force this. Now you cannot brute force. All right, so we cannot brute force, so we just create one edge, right? Create one edge. Yeah, for this case, 0 connected to anything, then it will be good. So basically, for a tree, you will have one of the nodes, right? Will be the connecting nodes, and you can think of that node as the root, right? And you want the root to have, you want the tree to be the shortest, right? To be the shortest. Yeah, we can use this as example. So if you take 0 as a root, you got 2. If you take 1 as a root, you got 1, 2, 3, right? If you take anything else, you got 1, 2, 3, right? 1, 2, 3, 1, 2, 3. So 0 is the smallest, right? On this. And here, if you take 0, got 1, 2. Yeah, I think it's also 0. So basically the 2, 0 connect, and that will be 2 plus 2 plus 1. So it's 5. Yeah, that's a 5. So the question is how to find the node that if it is considered as the root, then you will have the shortest height, right? The lowest height. Now, we don't know which one to go, so one idea I can have is go with topological sort. I think topological sort might work because a leaf will definitely not going to be the root, right? Unless you are in this situation, right? If it's not this situation, you have at least one more node, then the leaf will not be, because if you start from the leaf, it's always going to be longer. So you can remove the leaf, right? So if we do topological sort on this tree, you know what? As I'm just start talking, I think topological sort sounds like the way to go. Like it makes a lot of sense. It makes perfect sense to me now. But we just need to prove that it works. First, show that it works. Okay, so topological, first one will remove this, right? And then remove this, and then remove this. And then we'll remove this, and then we have a 0. And the number of levels the topological sort happens is the height. Okay, so how do you do topological sort? Topological sort. We have 10 to the 5th, so we can use, because I need the in degrees, right? I need the in degrees. Not really in degrees, just degrees, right? Degrees. So these degrees are 1, and you need a priority queue. Okay, so priority queue, we pop the ones out, and then I have to update this. Update its degrees, right? Update its degrees. But it'll be pretty hard to update the degrees if you use, unless you have to use a set, right? So because you remove it, you'll remove one of its children. So we do that, and then so you put it. That's not really a priority queue. It's just a queue with only ones. And once you're done, you know what? I actually don't think this one's that hard. If you really go down the topological sort type of deal. Okay, let's try this. Let's try to solve this, maybe in 10 minutes, okay? I think you shall be able to get it. So we do need to create, will map be an easier way? Can I do a map? Actually, I've never done a map before. So I have M and N. Just 1. What's the length? N minus 1. Right. So we can say edges 1 dot size plus 1. Edges 2 dot size plus 1. Right. And then we need graph. We do need graph. That in degrees we can use that, but the graph. Well, okay, so this is what I'm thinking. I say we can do set of int graph 1 n. Right? I think we can do that. And then we do the exact same thing. Graph 2 m. Okay, and then for auto e of edges 1. I'm thinking maybe I can simplify this. Yeah, I think I can simplify this. Okay, we'll say private. Okay. Std set int I'm not sure. Oh my god. Get graph. Does it work? Maybe it does work. Lordy. Oh wow. Okay, I have no idea. I have absolutely no idea. So that is not what I want. Do I have to do this? Function cannot return array type. I don't think so. Okay, this is C++. Function return array of set. How do I do that? Oh, I use a vector. Huh. Okay, maybe we should use a vector. Yeah, I don't know how to return. I have literally no idea. You can pass pointers to arrays. Screw this. I'll use vector. I'll use vector. It's the same thing. Okay? Well, not exactly the same thing, but it's close enough. This I can do, right? And I'll say vector std set graph like that. Okay, and for auto e of edges, don't you need? That's fine. That's fine. We just do graph e0 dot add e1. Okay, graph e1 dot add e0. Boom. It's not add. Insert. Okay, so we don't need this. No need, no need. And I just say auto graph1 equal to get graph edges 1 auto graph2 get graph edges 2. Right, so we got a 2 graph, and then we need to run. We can put here. All we need is int get minimum height. Alright, so we need a std vector std set int graph. Okay, I say int n shall equal to graph dot size, and then we say int degrees. You don't need degrees. You don't need. So we just need a level. Okay. What else do we need? We need a Q. We need a Q. Then we need a Q. Q of int Q. Okay. And then for we have to go through graph to find it as 1, and then we push it in. Right, so for auto children of graph. Right. Oh, that's not right. I0, I smaller than n, I plus plus. If graph I dot size is equal to 1, q dot, oh, what did I do? Q dot push I. Okay. While q dot empty, q is not empty. Alright, if q is not empty, int node is q dot front. Right, we do a front and then we do a pop. Because you in at the back, you pop at the front. So we got a node, right? And we need to do is for its children, for int children of graph node graph c dot remove delete erase or erase node, right? If graph c dot size is equal to 1, then q dot push c. Ooh, that's actually not how you're supposed to do this, because I need to know your level, right? We need to know the level. Okay, that's fine. Int size, say size equal to q size for int j equal to, I can say I equal to 0, I is smaller than size. Wait a whole second. We can say while size is larger than 0, right? Then we will do all these things inside. Size equals 0. Then we'll get a node, we'll pop it, we'll erase the node for all its children, right? So when it becomes 1, q will push, okay? And size minus minus, because we've done 1. And then once we're done, coming out, level plus plus, right? So we handle this, so we go for the next one. That's, you have 1 level, right? And eventually you got the end. I think level is, yeah, let me just think. The initial level is 0, right? So I handle everybody, we push it to the next level, level go 1. And next level, you know what, I think I should level it, the level first or level at the end? Because if you have in 2 levels, right, you go in, you pop everybody out, then you add the next, right? You go through everything, and eventually you will push the C. Right, so the graph node, so all its children. Yeah, this should be right. And then size minus minus, right? So you handle the current. Eventually you handle everybody, and then you have the Q have a new thing. Then you plus plus, you handle this level, right? You go up, and then for this Q, let's say it's only 1, okay? So you get it out. For these children, there is basically nothing because you have deleted. Right, there's nothing, then Q becomes 0. So I think when you return, shall return this, minus minus, right? So now we can just return get mean height graph 1 plus get mean height graph 2 plus 1. All right, let's take a look at our example, see if it works. Works for the second one, the first one doesn't work. I think it's because, so in this case, right, in this case, height is 1, but when I start, I say level is 0, right? And then I put both in. Ah, that is true, you put both in. And then we say, we'll get out, 0 get out. And we look for the next. So this will remove 0. And it's equal to 0, so it doesn't push. Okay. And then we go to the next one, which is this. And this, because we are, all right, so we need to count the number of nodes. Okay, count the number of nodes. When we have only, yeah, so there are 2 scenarios. One is you remove everything and you got 1 left, right? And the other is you remove everything, you remove something, right? And you got 2 nodes left. So when 2 nodes left, that's a different scenario. Okay, so basically what we say, and this is still fine, and this is still fine. And I say if it's equal to 1, and if it's equal to 0, I can't even remove. I can't because I know the size. I'm not using n anymore, so I know the size, right? So, and n is larger than 2, okay? So we do this, right? And we say, so every time when you pop it, you will reduce that amount as well, right? Yep, size minus minus, and n minus minus as well. Okay, n minus minus as well. And then you have, level plus plus. Now you get down to n equal to 1, right? Then you get out. And when n equal to 1, yes, you do minus minus level. Now when n equal to 2, that's the scenario. So when n equal to 2, you just return level, right? When n equal to 2, you return level. So basically here we shall say n is equal to 2 level, otherwise we'll return this. Okay, so a little change. Let's see if make it work. Oh, does not make it work, dude. Do you want to debug this? Oh yeah, because I start with 0. Oh, hold a second. Hold on. So if we say n larger than 2, so if it's already 2, so we're just gonna skip. So we should return 1, right? So if it's 3, right? If it's this situation, then we'll find this, right? We'll find this, so the size is 2. So we got this, right? So this is the children, or remove, so this one will remove, and oh, look at that. Once I remove this one already equal to 1. So I push this in. That is interesting. And then I'll handle this one. Right? I'll handle this one. This is also remove. Now this becomes a 0. So I don't push in again. Right? And the next round, this one actually comes out. Right? This one actually comes out. This one actually comes out, but it doesn't have anything. So size minus minus, right? And n minus minus. So well, yeah, we don't have any. So this one is gone. Yeah, this gets it comes out. And the level plus plus. So in this case, it does give, so the first level plus plus, and then second level plus. So this one does give you 2, right? So you need to minus minus. But what if we have, not really. I think everything else will be, because the topological sort of always going to be like this. So the only situation is this. This is the only one, because you can't add another one. You can add this, you can add this, I don't know. Oh, you can. So this one, you'll remove this. Alright, we'll remove this, and this gets put in. And you remove this, this gets put in. Right, so in this case, you do these, level become 1. And initial equal to 2. Yeah, this one has not been added yet, because n is already equal to 2. N is already equal to 2. But why would it matter? So I'm here, right? So this has 1. So I pop this, and then I basically cut this. And this becomes 0, so it doesn't go. And I do this, it doesn't go. And at the end, level plus plus. Right? And then 1, 2. Because this is will keep the level. This we have to. Yeah, it doesn't matter if it's 2. So it should be whatever level plus 1. So you're telling me that if it's this, it should be plus plus. Okay, now I'll go back to 2, but the first one is still not right. Oh, I think it's because I shouldn't. Because after this, right, I don't move on. Yeah, because this is the last one, and yeah, that's because I don't move on. There you go. Let's see if we got lucky. 333203. Topological sort. To find the minimum height of each tree. The answer is the sum of the minimum heights plus 1. I'm still thinking why I cannot do it. I mean, if we do it, it just means at the end, you cannot minus in this situation, but we need to differentiate the two. Okay. I guess that makes sense. We can try. Nope. It's not right. Okay. Alright, we'll have 0, 1, 2, 0, 3, 2, 3, 6, 8, 7. Okay, 8, 7, I don't know. 4, 8, 4, 5, 3, 5, 3, 9. Okay, 5, 5, and so 4, 4, so 8, 8, also 7. Oh, I see. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. And the other one is 0, 1, 0, 2, 0, 0. Okay, this one is 1. Easy. This one, if a topological sort, I would remove these two first. Right? And remove this, then remove this, then remove this. So the total I will be consider this as the height. This is at the root. So basically 1, 2, 3, 4, 5, 6. Huh? The answer is 7. Hey, hold on. Hey, what if I go with 3? That 1, 0, 0, 2. So it's undirected, right? 0, 1, 0, 2, 3, 2, 3, 6, 8, 7, 4, 8, 5, 4, 3, 5, and 3, 9. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 1, 2, 3, 1. So once I connect these two, zero, 1, 2, 3. Isn't that 1, 2, 3, 4, 5, 6? Where is the 7? I don't understand. Where does 7 come from? I don't. Expected 7. What in the world? Okay, I'm gonna make some changes. Okay, so this I'd expect to be 1, 2, 3, 4, 5. Oh, Lord. Okay, 1, 2, 3. So 9 has to be 4. Yeah. 1, 2, 3. Oh, it's actually no. We remove this, remove this, remove this, remove this. Because 0, 2, 3. 0, 2, 3. So that's 1. 0, 2, 3. I remove one of them. Remove two of them. So that's 2. So we start from here is 2. 1, 2, 1, 2. Yeah, 2. 3, 4. Okay, that's actually good. Alright, now we're gonna make changes. So 5, 6. We add a 7. Okay. We add a 7. Hold on, let me change this. So basically this is 4. Okay, 5. So let's say we add a 7 here. Okay. So we add a 5 to 7. So 5 to 7, basically we have 5 to 7. So this is a 4. Alright, 5 to 7. I think it'll be 3, 3 plus b. This should be 5. One, 2, yeah, 5. Okay. Now we add an 8. 7 to 8. That's 6. Oh. 2, 3. 1, 2, 3. Okay, I don't understand. Why do you expect is 6? What condition I didn't? Okay, so tree with no number. Yeah, two integer array. That's just regular edge between. Okay, you must connect one node from the first tree. I said connect 3 with another node from the second tree with an edge. Right, second tree will be here. We'll connect an edge to the minimum possible diameter. So basically I say if I connect this to 0, 1, 2, 3, what's the smallest diameter? 1, 2, 3, 4, 5. What in the world? You kidding me, man? That is neither here nor there. Where does the 6 come from? Length of the longest between any two nodes. I don't understand. It doesn't make any sense. It doesn't make any sense, honestly. I don't understand. Why is this the answer? How do I even handle a situation like this? That I think it's not right. You need to convince me. I am not convinced. So you're telling me any two nodes will actually give me a longer? How? Huh? What the hell? That's actually true. I didn't consider this one. Oh, 1, 2, 3, 4, 5, 6. Holy crap. Oh. Damn. Okay. Okay, I see. I see. Yep, yep. I need, oh my god. I need to find the longest and within this. How do I find the longest within this? I don't know. Um I can get the minimum height. Right? So from someone who'll give you the minimum height, but what should I do to get the largest, longest? I think it should anchor at the smallest. Oh, how do we find that? So if we get down to 1, then it's just a double. Okay? Yep, and then will be double. And if we cannot get down, so like if we eventually get down to have 2, right? That just means it has to be double plus 1. Okay, so basically what we're saying is get the mean height and max diameter. Okay, so if it's equal to 2, then we shall return a pair. Okay, so we say then we will do as the mean height and then is equal to 2. So you say level into plus 1 or 2 times level plus 1. Yeah. If it's not, then level and then level plus level times 2. Pair. Okay, then auto P1 get mean height graph 1 auto P2 get mean graph 2 return t max Actually, how do I get a max? C++ max function. A/B comparator. Oh, I can do this. So I can do max p1 dot second, p2 dot second, p1 dot first plus p2 dot first plus 1. We'll have to say it's hint. The hint is very important as it points out the diameter of the final tree is the max of first tree's max diameter, second tree's max diameter, and then first tree's minimum height, min height plus second tree's min height plus 1. That's actually quite important. Alright, let's see. I thought this one we can solve within half an hour. How wrong am I? Alright, let's see. Hopefully this one passes. Yep, it does. So, solution is correct. Just that little, okay? That little thing. So it's not really that hard, but actually no, it is hard. It's mainly hard because of the diameter. I didn't really realize you have to handle the diameter separately. Okay, so let's see the solution. That's actually better. Maximum diameter. That's true. You get a maximum diameter. You divide by 2, right? If the maximum diameter is even, then you divide by 2. If the maximum diameter is odd, you divide by 2, and then you take the larger, so you take the ceiling, right? Maximum amount of diameter of each tree. So how do you find the maximum diameter? Farthest of farthest of farthest. Alright, I only know to find farthest node. BFS. Yeah, so you start from one node, you do BFS, you get a farthest node. That's one way, right? Second way, from the farthest node to determine the diameter. So you take from any, you start from any one. Yeah, you start from any one, and then you will go to the farthest that they can go. And then you, wait, what? Then you go from, okay, just from 0 you get a farthest node. And then you go from n. And then from the farthest node. Huh? Wait, how? What? So in this case, huh? Okay, U does not lie on the diameter, and a path from U to the farthest node passes through the diameter. Why would it pass through the diameter? So we have a diameter. Because it's connected. Because it's connected. Since it's connected, you will always go through something on the diameter, right? And then when you go through something on the diameter, and if you keep going, you will always end up at the diameter. So 2 rounds of BFS can find the largest length. Alright, DFS, are we doing the same thing? To find the yeah, that's fine, because I saw topological sort. I can use topological sort. It's the same thing. Let's see topological sort. I think it's the same idea as me. But I only need to use a diameter. I think it's fine. It's the same, right? It's pretty much the same. I think the BFS idea is actually quite cool. To find a diameter. It's much simpler compared to topological sort. Because topological sort, you require not necessarily. Well, you have this remove thing. Does he use remove? You better. Oh, they have a degrees. They use a degrees. Oh, they use a degrees. But how do you go for the next round? Yeah, degrees minus minus, so you push it in. Oh, you don't care. You do not care. Decrease the degree. Yeah, you do not care because they can only hit one once. So that is where we can make things faster. Okay. I kind of want to try it. So, two things, right? Basically, we will not use a set. Oh my goodness. So basically, we'll say %s std set. We'll have to do std vector. Okay. Oh, jeez. All right, and then this will be push back. All right, this will be push back. All right, and here what we do is we will get their degrees. We can say I just call std vector int degrees n and then initialize 0, right? And then we say degrees I equal to graph I dot size. Okay, so all right, let's see. Yep. That I think will be an improvement. for topological sort, we don't need to use set in the graph, right? Instead, we just need a counter to keep track of the degrees, right? All right, hopefully we pass. Better. Oh my goodness. There we go. All right, that's it. 1 hour. I mean, the idea came, I think, not even 10 minutes. I got the idea, but I don't know what happened. The implementation took so long. We did have a little bit hiccup. Oh yeah, the hiccup took some time to resolve. I have to read the solution, read a hint to realize. But other than that, I mean, nothing too bad. But finding the longest diameter of a graph, that two rounds of BFS is quite smart. Very smart. All right, that will be it for today. I'll see you guys tomorrow. Adios.